Okay, so today we're going to learn about voltage difference and what that means. And as you know, the voltage difference between 2 points is what tells you the electric potential energy difference that a charge will experience if you move it from one point to another. So we define voltage difference by the relationship change in electric potential energy equal to charge that will be moving from one place to another times the voltage difference between those 2 points. So that's the definition of a voltage difference. It's a change in electric potential energy per unit of charge, and that's always true. Now today what we're going to be working with is a special situation where there's an electric field that's constant. And if we have a constant electric field, then we can simplify this one more step as follows. Change in electric potential energy will be the charge that's moving, and then voltage difference is simply going to be E times change in height. So that's true if we have a constant electric field. So what I want you to remember from the first part of this discussion is that what voltage difference means, an easy way to think about what voltage difference means, is it's the product of electric field and height difference. So a voltage difference is an electric height difference. That's what this relationship here is telling us. Now, that also means that if there's no electric height difference between 2 places, then there'll be no voltage difference between 2 places. And there's 2 ways that that could happen. Either if there's no electric field in the region, then there can't be a voltage difference. The other way is if there's no difference in height. And we're going to see examples of both of those in just a minute. So the demonstration that we're going to do involves a set of batteries, and as you know, batteries create a voltage difference. Their positive end has a higher voltage than their lowest end, than their negative end, and these are 1.5 volt batteries, and I have 4 of them, so that's overall going to be a 6 volt voltage difference between the positive end of this battery, this is the positive end of this battery, and the negative end of the last battery here will be 6 volts voltage difference. So that's what batteries do. They maintain a certain voltage difference. The other thing we'll be using is this voltmeter. A voltmeter measures voltage differences, and as you can see, it has 2 inputs. So one thing I want to emphasize in this demonstration is the concept of voltage itself actually isn't meaningful. The only thing that's meaningful is a voltage difference between 2 points. And so that's why when we measure voltage differences, we always need 2 input wires. That's also why with batteries, we can only talk about the difference in voltage between 2 ends. The third thing we're going to use in this demonstration is this black paper, which has some silver painted electrodes on it. So the black paper is coated with carbon. Carbon is not a good conductor, but it's a slight conductor. Silver is a very good conductor. It's a metal. So what we're going to do is connect these silver electrodes to positive and negative ends of the battery. I'm going to connect the positive end of my battery pack to this electrode, which is on your right, and the negative end is connected over here to the other electrode. So now we've made a voltage difference across these electrodes caused by the 2 batteries, which should be about 6 volts. Okay, I'm actually going to diagram this on the board here. So again, on your right, we have an electrode. It's going to gain a positive charge by being connected to the positive end of the battery. And over here we have another electrode. This one has a negative charge. I'll go ahead and draw the battery up here. This is the symbol for a battery pack. There's the positive end, there's the negative end. Because we've made a voltage, because we have a positive charge here and a negative charge here, those charges create an electric field in the region around them. And in this case, as you know, the direction of that electric field would be towards the left. So there's our electric field lines. And I drew them straight, parallel, and equally spaced because, as we know, if we have plates of charge, they make a pretty much constant electric field, magnitude and direction, in the space between them. So that's what we're creating here. Okay, so in the next thing I want you to notice, I'm going to make some measurements with the voltmeter, and I want you to write down the measurements because you're going to need these for class. So I'm going to take my voltmeter. I've got the red end in my left hand, black end in my right hand, and I'm going to keep the black end on this electrode here, which is attached to the negative end of the battery. The number you can see on the voltmeter is always going to be the voltage difference between these red and black inputs. So if I put the black at the negative end, which is a lower voltage, and the red at the positive end, which has a higher voltage, you should see that the meter records, okay, it's about 5.09, 5.1 volts, it looks like. All right, that's the voltage difference. Now what I'm going to do, as we were saying at the beginning, a voltage difference means an electric height difference. So we have an electric field here. The lowest place in this electric field is to the left, because that's the direction the electric field is pointing. The highest place is over here on the right. So I'm going to leave my black lead at the lowest place, and I'm going to gradually move my red lead towards the other end, which has a higher voltage. So hopefully you'll see on the multimeter that the voltage difference changes. All right? If I put it right here, I get that voltage difference. If I put it right here, I get that much voltage difference. I'm moving the red lead in equal increments of distance away from the black lead electrode. And you can see what's happening to the voltage difference between the red and black. And now it's back up to about 5.1 volts voltage difference. So what we're seeing is the greater the height difference between the 2 points in the electric field, the greater the voltage difference. All right, I'm going to show you 2 more things. What if we put, let's pick a point here, and put the black lead down at that point. What if I put the red lead down at a position that's at the same height? In other words, what if I measured the voltage between these 2 points, which are, neither one is higher or lower in the electric field? What do you think the voltage difference is going to be? Well, let's try it. The voltage difference is pretty much 0, right? And that's because, not because there's not an electric field, but because there's no difference in height between those points. All right, the other thing that I would like you to notice is, what if I put, let's go back to my black lead on this electrode, which is a conductor, it's silver. What is the voltage difference between that point and another point on that same electrode? Well, as we've discussed, conductors, by their nature, in equilibrium conditions, can't sustain an electric field in their interior. So inside all points in this conductor, if it's in equilibrium, which it is, there should be no electric field. Well, if there's no electric field, what should be true about the voltage at different points? Well, voltage difference is electric height difference If E is 0, then there should be no difference in voltage. So the voltage should be the same at all points. So let's test that. The voltage difference between these 2 points actually is very close to 0. If I move to any other point inside the silver, I'm getting very close to a 0 voltage difference between all these points. Again, that's because the silver is a very good conductor. So just to summarize, what we've talked about is the idea that voltage difference means electric height difference. The higher you go in an electric field, the higher the voltage will be compared to the point you started at. And in conductors, where there is no electric field, because of this relationship, there's also no voltage difference. So now that you've seen the data, the demonstration, and you've gotten some data, you're going to bring to class a graph and a diagram with some information that you should have gotten from the video, and we'll take it from there in class.